Welcome back. This is an Aleks homework video on counting significant digits. Significant digits, remember, is basically dealing with zeros. So if you have a number like 21, there's two digits in 21. There are two significant digits in 221. But if I say that it's 93 million miles to the sun, that doesn't mean that all of those digits are significant. Nobody's measured to the exact mile to the sun. They'd probably get burned if they did that. So it's a guess. So if I say 93 million, it's give or take a whole million. So there are only two significant digits. All those other zeros after 93 million, all those other zeros that are holding places, are just telling you that it's in the millions of things. It's not to the mile, but to the millions of miles. So any zeros at the very end of a number or leading up to a very small number, say 0.000021, all of those zeros leading up to it are insignificant. They're just placeholders. So trailing zeros and leading zeros are just placeholders. There's a number of rules that you can look at. It's in the textbook, and I'll explain it in class. But that would help you to know which are significant and not. But really, it's the zeros that are the problem. So let's look at this first one. Which one are significant, which ones are not? The rule says that leading zeros are insignificant. So zeros leading up to a number, so 0.00, those are insignificant. They're just holding a place. This 69 is really your significance. These are placeholders. I told you that trailing zeros or following zeros are also insignificant. The exception would be like this number. It's two zeros after a non-zero decimal after a decimal point. So this is showing you that this is actually significant and this is significant. So if I were to say 93 million and I put 0.0, then what I'm saying is I've measured that all the way to the distance to the sun, and I've measured it all the way up to 1/10 of a mile, and that is showing that that's a very accurate measurement, the 1/10 of a mile. But if I were just to say 93 million with no decimal point, all of these are insignificant. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, there would be 9 significant digits here. In this case, there would be 2 significant digits. So this and this are significant. These are insignificant. So this would be a number 4 significance. Okay. Also, the decimal point shows you that the ones in front of it are significant. So if I were to say 93 million with a decimal point, that's showing that I have measured it all the way to the mile, and this is accurate to the mile. So this one with no decimal point, there would be 2 significant digits. The one with the decimal point would be all of these, 1, 2, 3, 4, 5, 6, 7, 8. This would be 8 significant digits. And then any zeros after that decimal would also be significant. So this would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be 9 significant digits. Okay. So let's look at this one. I've got 8, 6, 8, 6, 6. These are all significant because non-zero digits are. These two normally would not be. These would be trailing zeros, so it should be 3. But that decimal point tells me that this has been measured to the 1, to the kilograms place, and that they're all significant. So this is going to be 5. Okay. So let's look at this number. It's a negative number, but I'm looking at the places that are significant. Now, I would call this a George Washington's white horse problem. Anything expressed in scientific notation, okay, something times 10 to the something, that's the number of significant digits. It's 100% of the time you'll know. If you have something insignificant in scientific notation, this will be your 2 significant digits. So negative 7.0, that's 2 digits. There are two significant digits in that number. Here's another one like that, 2.2. That's 2 significant digits. Hope this helps.